Alright guys, how we doing? Welcome to a video on writing the products for composition and decomposition reactions. This is a little bit different than what you guys are probably used to. Typically you would see this in class, and for homework you would get assigned a bunch of practice problems and you would give them a try at home. We're going to flip it around here, and you guys are instead going to watch this for homework, how to do these problems, and then when we get to class I'll give you guys some practice and you'll be doing those in class instead of at home. Gives you the opportunity to ask for help if you get stuck, either from me or some of the people that you're sitting next to. Some of the stuff you're going to need to do this, obviously Unit 3 packet. So you want to turn in that Unit 3 packet to whatever page you need to. It should say Predicting Products for Composition and Decomposition Reactions at the top. You want your blue comp-decomp cheat sheet that I gave you guys in class as absolutely a necessity here. You guys are always going to get to use that on tests or quizzes. So you want to get used to using that at all times. And then finally, your periodic table would be helpful as well. So I'm going to walk you guys through the general strategy for how to approach problems like this. And you basically approach all of these the same exact way. So the first one on your paper says aluminum plus oxygen. First thing you need to do is figure out what category reaction that is. What reaction type is that? Well, aluminum is an element, oxygen is an element. Element plus an element, two simple substances, adding them together, it's going to give you a composition reaction. The first handful we're going to do are actually all composition reactions. So once you figure out it's a composition reaction, you want to go to that blue comp-decomp cheat sheet you guys have and figure out what composition reaction is this. That's going to help you guys predict the correct product or products. So for this one, number one on this list here says metal plus a nonmetal. You're going to say, all right, well, aluminum's a metal, oxygen's a nonmetal, so that might fit. And while that's true, there's probably one better option on here, which is actually number two. Number two says metal plus oxygen, and that's really what we have in this equation. Aluminum as your metal, and then plus oxygen fits in here with category number two. So when you take a look at that, you want to find out what your product is going to be, and your product says metallic oxide. All you need to do here is substitute whatever metal you have in your equation into where it says metallic, and you guys are going to have whatever your product is. So let's go back to your packet here, and let's write this in and see how we finish off this problem. First thing you want to do on the left-hand side next to aluminum plus oxygen is put reaction type and category number, and that is going to be C2. So write that in, and then for a C2 reaction, you're going to make a metallic oxide like we just said. So aluminum is our metal, and then you just put oxide after it. So write aluminum oxide in for your word formula first. After you write your word formula, it's basically, the hard part is basically over from there. Everything else should be really simple. If you've been studying your ions, been doing okay on those TGIF quizzes, it's all about writing formulas for whatever compounds, elements, molecules you have listed in your equation. So to go through and finish this off, we have aluminum, symbol is Al. Oxygen, we have to write as diatomic, it ends in GEN, so it's one of our 7 diatomic elements, has to be written as O2. And then aluminum oxide is a common ionic compound. So reminder for how to write formulas for that, you want to find out what the symbol and charge is for aluminum. It is +3, so you can write it above or next to that if you want to. Oxide's an O-2. So when you put these two together in order to give the proper formula for this ionic compound, you're going to have Al2O3. You don't want to stop there. You want to balance this equation. That's always our last step in all of these for all 5 reaction types that we have. So take a look on the right hand side. You have Al2O3. Anytime you see an O3 like that, you have that odd number. You want to try to make that even. To make it even, multiply it by 2 to give you 6 oxygens. Put the 2 in front. Now just balance the rest of it. You have 4 aluminums on the product side. You want to get 4 on the reactant side, so you just put a 4 in front of Al. And then you have 6 oxygen on the product side over here, so you want to get 6 oxygens on the reactant side on the left, so you just put a 3 in front of the O2 to give you 3 times 2, giving you 6 oxygens on the reactant side. Once you do that, it checks, it's balanced, you followed your blue cheat sheet, you're done for the first problem. Okay? So, if you have any questions on that, I guess that's too bad, because you're going to be asking them or talking to a computer. It's kind of weird. So if you have a question on this, you could ask me about it in class next time you guys see me. In the meantime, we'll go on to equation number 2, and that's calcium oxide plus water. So like I told you guys, these are all composition reactions to start out here. So go to your blue cheat sheet and figure out what category best fits reaction number 2 on your paper. So calcium oxide plus water, as you go through the list down here, you should see down by number 4, it says metallic oxide plus water. Calcium is a metal, so that would make sense as the best answer here, or the best category for the reaction that we have. So calcium oxide is your metallic oxide plus water. Product is going to be a metallic, in this case calcium, hydroxide. So once we figure that out, go back to your packet here, and let's fill in the rest of this on our note sheet. So first thing you want to do is fill in reaction type and category number. So this one is a C4, and the product is a metallic hydroxide. So calcium being our metal, you write calcium hydroxide as your product. Once again, this is the most difficult part. Once you do this, the hard part's over. It's just writing formulas and balancing equations from here on out. So to write the formula for calcium oxide, calcium is a +2, oxide is a -2. Put them together and you get CaO. Water, write the formula for that, H2O. And then calcium hydroxide, calcium is a +2, hydroxide is OH -1. So when you write the formula for that, you're going to have Ca and then parentheses OH, close parentheses, and a 2. Last step is going through and balancing it. This one's a real brain buster here. We have 1 calcium on each side, 2 oxygens on each side, and 2 hydrogens on each side. So this one is very simple to balance. It's a 1 in front of everything. Or, of course, if you don't want to put the 1s in front, you can just let it go and just leave it how it is. All right? So that is example number 2. One left for you guys to go through here, and then I'm going to have you guys practice some on your own here, and then you can pause the video and see if you got them right or not. Equation number 3, sodium plus chlorine. So first step, always go to your cheat sheet. Here it is. Sodium, you should know by now, or at least recognize that sodium is a metal, and then chlorine is a non-metal. So best category is number 1. Metal plus a non-metal yields a salt. All right, for this one, when you guys think of salt, you think of NaCl, you think of table salt. While that's true, there are many kinds of salt that exist. In fact, any ionic compound at all could be called a salt. It doesn't need to be NaCl. It could be calcium chloride. It could be potassium chloride. It could be silver nitrate. That's a salt as well. So just because it says salt, don't just write NaCl. You have to look at what your metal is and what your non-metal is. Of course, for this example, your metal happens to be sodium and your non-metal happens to be chlorine. It doesn't always happen that way though. So first thing you want to do, put your category, number, reaction type. It's going to be a C1. And then your product is going to be a salt. Do not write salt as your product. Okay, you want to write down what it actually would be, what the ionic name is going to be for this. So it's going to be sodium chloride. Again, hard part's over with. Just write your formulas. So sodium is Na. Chlorine ends in INE. That's diatomic, so you have to put Cl2. Yields and sodium chloride. Very easy formula to write. Sodium is a +1, chloride's a -1. Put the two together and you get NaCl. Final step, balance the equation. The only thing not balanced right now is the Cl. 2 on the left, 1 on the right. So you want to put a 2 in front of NaCl right here. And then all you want to do to finish this off is put a 2 in front of the Na on the reactant side to give you guys 2 of those on each side. So you end up with 2 Nas on each side, 2 Cls on each side. You can put a 1 in front of the Cl2 if you want to, and then you guys are finished. So that was our third example. There are other kinds, right? There are 5 different categories for composition reactions. We did 3 of them here, but they all follow the same general pattern. Look at your reactants, go to the blue cheat sheet, figure out what your product is, write formulas, and balance. Okay? What I want you guys to do now, and we're going on the honor system here since I can't actually see you do this. That would be kind of creepy. You guys want to pause the video right here, and you want to do equations 4 through 6 on or in your packet. Okay? Give them a try. Take like 5 minutes. Go through, look at your blue cheat sheet, categorize them, write your products, balance it, and then unpause the video, and you guys will be able to see the answers for those next 3 problems. Okay, so pause it now, give them a try, and then come back here and see how you did. All right, guys, hopefully you gave those a try, and if you take a look at the answers here, this is what we end up with. The first one you guys had to try was a C2. It was a metal plus oxygen, very similar to the first one we did. So you're going to make magnesium oxide as your product. I have the ions written for you above or near the name, so you guys can see how I got these formulas. The second one you guys had to do here was actually a C5. Haven't had one of those yet. So you made an acid. Easy way to tell what acid you're going to make. Super simple. You want to look at what your nonmetal is. Your nonmetal here is sulfur for that second one you guys had to do. The only acid we memorized or even talked about very much is sulfuric acid, H2SO4. So you know you had to pick that one because it's the only acid we learned that has sulfur in it. Last one is a C4, which is a metallic oxide plus water. You're going to make lithium hydroxide, and you guys can see what your product is there. And, of course, the balanced chemical equation when all is said and done. So that's it for learning about composition reactions. Just a couple more minutes left here. I want to talk about decomposition reactions since they are on the same cheat sheet. And really, once you understand composition, you're going to do the same thing for decomposition. You just have a couple extra categories and a couple extra, kinds to worry about. But overall, it's the same general strategy for all of these. So, taking a look at reaction number 7 on your paper, it says copper 2 sulfate pentahydrate. You guys know this is a decomposition reaction because you're only starting with one substance on your reactant side. It says copper 2 sulfate pentahydrate. It's not adding anything. There's no plus sign. So it has to be decomp. Go to your cheat sheet. You see the 7 kind here. And these are super, super easy. Anytime you get a hydrate, you should be thanking me because you should get 100 on this. You should get it correct every single time. It involves very little thought at all to write your products. So we're in category decomp number 1 here. A hydrate produces an anhydrous salt plus water. Anhydrous salt is just a salt, an ionic compound, that does not have water attached to it. And you can see that because it now says plus water. Water has been removed. Those bonds have been broken from the salt. So to write your product, it is extremely, extremely easy. You're going to rewrite copper 2 sulfate, and then you're just going to put a plus sign and then water. Okay? So this is a D1, decomposition number 1 reaction. Now, all we have to do is write the formula for this. So copper 2 sulfate, copper 2 is Cu plus 2, sulfate SO4 minus 2. When you write the formula for that, it is CuSO4, and then penta means 5, hydrate is water. So CuSO4 dot 5H2O. Well, guess what? Look at your products. It's copper 2 sulfate again, and then it says plus water. All you have to do is take away the dot, put a plus sign, and you're done. It's already balanced for you as well. CuSO4 dot 5H2O yields CuSO4 plus 5H2O. We're just breaking apart that loose bond here with those 5 waters, and then those 5 waters will be removed, and you're just ending up with CuSO4 plus 5H2O. All right, guys, so that's the first one. 2 left as, oops, sorry. You can put a 1 there if you want to, doesn't matter. Equation number 8, second to last one we're going to do together here. Sodium bicarbonate. So again, blue cheat sheet, figure out what kind it is. Sodium is a metal, right? So you have a metallic bicarbonate. That is number 6 on here. So products, you're going to actually have 3 of them here. You have a metallic carbonate. So again, here's where our ions come into play. Plus H2O, which is just water, and plus CO2 gas. So keep that in mind as you go back to your notes. Write in the reaction type and category. Metallic bicarbonate is going to be decomp number 6. And your products, you're going to have your metallic carbonate. So metallic being sodium for this one. Sodium carbonate plus water and plus carbon dioxide. Hardest part's finished. All you need to do now is write your formulas. So sodium is Na+1, bicarbonate HCO3 -1. Nice and easy. They're both a 1 with their charge. So you make it NaHCO3 yields now sodium carbonate. Let's write the formula for that. Take a look at it. Sodium is a +1, we know that. Carbonate is CO3 -2. So the formula would be Na2CO3 plus water, which is just H2O, and carbon dioxide, which is CO2. Final step, got to balance it. A lot of stuff going on here, a lot of oxygens everywhere, a couple carbons everywhere. So I typically ignore that stuff and focus on my metal. So my metal is sodium. I have 2 over here on the product side and only 1 on the reactant side. So easiest thing to do, put a 2 in front of it on the reactant side and then see if that fixed things, and it looks like it did. 2 NAs on each side, 2 H's on each side, and then 6 oxygens on each side. So put a 1 next to everything else if you want to, and this equation is finished. All right. So you guys can see how important it is to know, what are your ions? What is the carbonate ion? What's the bicarbonate ion? If you don't know those, it's going to be really hard to write the formulas for this. I mean, right now, for homework in class, you can always double check your gray periodic table or your ion list. But of course, you're not going to have that when it comes time for a quiz or a test. So you want to try to get used to not using that stuff. Last one, potassium carbonate. So, blue cheat sheet, go to it, figure out what kind we have. Potassium is a metal, right? And then you have a carbonate. So you have a metallic carbonate. That looks like it's number 5. You're going to make a metallic oxide plus CO2 gas as your product for this one. So your metal is potassium. You're going to make potassium oxide plus CO2. So let's fill in what we need to on our note sheet. First things first, reaction type and category. We have D5. And then write your product, or I guess your products, since it's a decomp reaction here. So we have potassium oxide plus carbon dioxide. Straight from the cheat sheet, nothing to think about, just substitute your actual metal into where it says metal or metallic on your cheat sheet. That's all you gotta do. Write the formulas. Potassium +1, carbonate CO3 -2. That makes K2CO3. Produces potassium oxide. So potassium is a +1, oxide is a -2. So your formula is going to be K2O plus carbon dioxide, which is just CO2. Another brain buster here. If you take a look at this one, looks like it's all balanced. So put 1s across the board or leave it blank. Your call. Okay. That's it, guys, for equation number 9. So just like we did for composition reactions, there are 3 of them left on your paper. So please give them a try. Look at your blue comp-decomp cheat sheet. These are all 3 going to be decomp reactions. So give them a shot, pause the video, come back in a couple minutes, hit play, and see how you guys did on these last 3 chemical reactions. All right, so hopefully we paused that. Tried them, take a look at them here. The first one you guys had to do is going to be a D2 reaction, metallic oxide, decomposition of a metallic oxide. So you're starting with calcium oxide. Break it down into calcium plus oxygen. Be aware here, oxygen is written as O2 since it's diatomic, written by itself. Balance it pretty simply by putting a 2 in front of the CaO and a 2 in front of the Ca, 1 in front of the O2. Next one is just like one of the first ones we did, which is a D1 reaction, which is a decomposition of a hydrate. This time it was magnesium sulfate heptahydrate. So take a look at what we did. Simply write the formula for magnesium sulfate heptahydrate, so that's .7H2O. Put the yield sign, put the same exact thing, except take away the dot and put a plus sign. Last one, strontium nitrate is a decomposition number 4. So we had a metallic nitrate. A lot of mistakes happen with this one, guys. So just if you're actually still listening to this video, that's good, I guess. Keep listening for a couple more minutes here. When you have a metallic nitrate and that breaks apart, it forms a metallic nitrite. So you can see on the screen, I underlined it for you, put it in bold. Strontium nitrate yields strontium nitrite plus O2. Really, really common mistake right there. For some reason, students want to put strontium nitrate yields strontium nitrate again plus O2. It's just not the case. So you know what nitrate looks like. It's NO3. So nitrite ion is going to be NO2, just one less oxygen there. So I have the ions up here on the screen for you. You guys can see those. And then that one was not very tough to balance either. You just had to put a 1 in front of everything. So that's it for the composition decomposition reaction tutorial here. Keep this video in mind. Don't just watch it once and then kind of forget about it. If you guys ever get stuck, if you ever need help on doing composition or decomposition reactions, if you study, when you study, you can always go back to this video and watch either the beginning or the end or the whole thing again, certain sections, to kind of remind yourself on what to do or get some extra help when you need it. So that's that, I guess, and hopefully we did okay with these, and we'll do some practice next time I see you guys in class. All right, that's it. Have a good day.